Glaciers in the Pacific Northwest are melting faster now than ever before, and that melt has a domino effect on our water supplies and ecosystems. Thank you for joining us for our Environment Northwest special, Glaciers on Thin Ice. I'm meteorologist Leah Pizzetti. We begin our series in the North Cascades with a team of scientists who have been making this journey for more than 4 decades. I backpacked with them and got a first-hand look at the alarming discoveries they've made. It's a powerful sight. A glacier. This one more than 5,000 years old. But for as old as it is, the end of its life is quickly coming.
As soon as we get to the snow, we'll put on the crampons.
Maury Pelto has been meticulously documenting this glacial melt for more than 4 decades.
There's the observer mode. You're just taking the measurements and trying to understand what's happening so you can tell the story. But then later, when you reflect, it'll get to you.
For him, this loss is personal. The Lower Curtis Glacier in the North Cascades is just one glacier Maury monitors each summer. Every July and August, he and his team spend 3 weeks in the North Cascades. This summer, they'll hike to 10 different glaciers. This project started for Maury in the 1980s when climate leaders knew mass melting was about to intensify. So they advised that monitoring start immediately to understand the scope. Maury chose to devote the next 50 years to documenting the North Cascades. That was 1984. Now, 42 years later, and he's seen with his own eyes how far glaciers like this have receded.
Like a lot of glaciers, you can see where it's really struggling. There's a wall on the far side of the glacier, a little couloir that goes up, and there's a ton of rocks poking out through that. And that used to be just a smooth snow face. We'd just walk right up it. And so when you start to see rocks emerging from below the glacier in an area that should be an accumulation zone where snow never melts, that's when you know the glacier can't survive. After decades of data collection, he's now responsible for 3 of the world's 60 longest documented glaciers called reference glaciers. 2023 was the first year when every single glacier in the network had a lost mass the same year. In 2024, it happened again. So that's telling you it doesn't matter what mountain range in the world you go to, the story's the same. In the U.S., there are only 8 states that have glaciers. Half of all glaciers in the lower 48 are found in the North Cascades, but those are quickly shrinking. When Pelto started his research in the 1980s, he says there were about 700 glaciers in this range. In the last 45 years, 100 of those glaciers have been lost, with most of them lost in the last decade. And the melting is speeding up. You can use me as a reference point. I'm 5'9". From 1984 to 2012, the average mass lost per year was about 2 feet. That number nearly tripled in the last decade. From 2013 to 2024, the average mass lost per year was about 5 feet 6 inches. So basically the same height as me lost every year. We'll laser the steepness of the tongue. Every summer, the team measures the slope and height and width of the glacier. You just count up the annual layers. We have about 35 years worth in sight here. They take measurements of the crevasses. We'll drop the instrument down and it'll hit the bottom. Perfect, right through the hole. Checking how deep they are.
21 feet.
They check the snowpack sitting on top. At this point in the year, we'd want 80% of the glacier to be covered in snow.
7.5.
But it now sits at 50%, meaning the melting snow will leave the glacier exposed and more prone to melting, expecting to lose 4% of its total volume this year alone. The team measures that melting outflow.
Kind of the flow direction.
This year, Maury was able to walk across the stream of ice-cold glacial water, a first and not a good milestone.
It's not a good change because that means the ice is retreating really quickly here.
That's Jill Pelto, Maury's daughter.
I'm going to be measuring some crevasses up there with the laser rangefinder.
This is her 17th year joining her dad on his summer research trip.
When she came out here after her sophomore year at high school, it was a tough year to do it.
I love getting to see these same places every year, and now my relationship with them is so intimate that it's hard not to just want to keep coming. and see how they keep changing.
But Jill brings a different set of eyes and skills to this team.
Art can be that connection, I think, between that kind of more factual information that can be technical, can be tough to understand, can be hard to relate to, and it can kind of, I think, break some of those barriers.
She creates art that is based off this glacial melting data.
I'll want the angle of the slope.
Working graphs and information into images.
Trying to dig into some of the stories of what we know about these landscapes, what we're learning and observing and measuring, and share like more kind of actual information with people, and also trying to really share like the kind of the beauty of these places and kind of the emotions tied in with that science.
This summer team is a mix of scientists and artists, bridging information and emotion.
For Jill, it was, she became my partner. And happily, it's hard to imagine doing this without her.
It became something that obviously has changed my whole life, and I think it shaped a lot of the people involved in the project.
The numbers are powerful. 20% of this glacier has been lost in the last 5 years alone. But as they climb inside,
you can't always get under a glacier like this.
They see signs that it's still alive.
I love the different light coming through the layers.
This cave is at least 50 years old.
You can really see under here how the glacier moves so much material, builds up.
But this will soon subside. This glacier is expected to disappear in Jill's lifetime. So every summer, they'll return, documenting the mass lost.
You think of that story, the Lorax who speaks for the trees, and we speak for the glaciers. It's not a happy story.
This father-daughter team chipping away at awareness as these glaciers slip away faster and faster. It's a similar fate in Washington's nearby Olympic Mountains. Research shows about half of the glaciers in that mountain range have been lost since 1900. The National Park Service says the Blue Glacier, one of the most studied glaciers in the world, has lost 178 feet of thickness in a 20-year span. Coming up in about 15 minutes, meteorologist Rich Marriott joins me. He extensively studied that glacier 45 years ago and will show the dramatic changes we're seeing there now. The beauty of the Three Sisters Mountains in Oregon can stop you in your tracks, but behind the snow-capped peaks lies a troubling shift. Glaciers that have defined Oregon's high country for thousands of years are melting away at a pace scientists say they've never seen before. Meteorologist Joe Ranieri hiked to Clark Glacier to see the changes firsthand and what they could mean for Oregon's future.
The Three Sisters are iconic to the Pacific Northwest, especially up here on South Sister, one of the tallest mountains in the entire state. But what we're starting to see with these snow-capped mountains are some big changes. There's a reason South Sister,
this is my fourth time,
is one of the more popular peaks to climb.
I mean, it's absolutely stunning. There's views almost the whole way because you're above tree line, which is great. It's also one of the few hikes where you can pack in a lot of elevation gain. So if you're looking for a good workout, it's a great one.
But as you climb higher and higher,
they are no longer having any snow left them at the end of the summer, and so that means they are going to continue to retreat and disappear under the current climate as it is today.
You're seeing more rock exposed up here at 9,000 feet instead of snow and ice.
The predictions from 15 years ago have now come to fruition.
Anders Carlson is the president of the Oregon Glaciers Institute. He's been studying glaciers for the last 25 years.
There are other glaciers that have disappeared around there as well. Irving to the north of that on Middle Sister. Eugene Glacier on South Sister is gone.
Carlson says glaciers are melting rapidly through the Three Sisters.
In the last 10 years, the state of the climate impacts on the planet, even down to the local area here in Oregon up in the Cascades, have just skyrocketed.
The glaciers up here on South Sister are slowly disappearing. Take Clark Glacier, for example. It's gone. It's now just a snowfield, but it's not just taking place up here in the central Oregon Cascades. This is something we're seeing across the globe. This is what Clark Glacier looked like 100 years ago. Now compare it to today.
Oh, and in its glory, it was 3-4 times the size that it is now.
Andrew Fountain is a retired geologist professor at Portland State University.
Our study, which is about to be published, showed that there's roughly somewhere between 40 and 50% glacier loss since the mid-1960s.
According to new research by the University of Northern British Columbia, over a 4-year period from 2021 to 2024, glaciers in Western Canada, the United States, and parts of Europe lost 12% of their total volume.
You just scale it up, over 10 years, then that is more than 20%. So it's significant.
Figuring out what's behind this is no surprise.
Well, it's all effective temperature shrinking these glaciers.
Our summers over the last decade are getting hotter.
Is just an acceleration of that trend that's affecting all the glaciers. When we have the heat dome, that's not good for glaciers.
So what will this area look like in the next 50 years?
As of the current level of warming is already too hot to keep glaciers in the Three Sisters region. They will disappear under the current temperature we have.
An unrecognizable landscape from what we're seeing today. For Environment Northwest, I'm meteorologist Joe Ranieri.
There really isn't a way to redirect it because this is driven by kind of our global climate changes, and we're not on a trajectory for a cooling planet.
Researchers say because of how hot summers are getting, it's very unlikely glaciers will rebound. TJ Fudge, a research professor at the University of Washington, says glaciers grow from consistent snowfall. When snow falls year after year, each season's fresh layer piles on top of the old, compressing it into dense ice over time. But glaciers need more snow falling in winter than what melts in the summer for them to thrive.
So if you think of glaciers as a little bit like a bank account, so you're always adding money from your job and taking it away for your expenses. But if you start earning less or you start spending more, that causes your bank account to shrink. And glaciers are the same way with ice. So if you have less snowfall in the winter, then the summer melt is going to be a bigger portion and it's going to shrink.
Another factor, the mountain ranges in the Pacific Northwest have been seeing more rain in the winter instead of snow. Coming up next on Glaciers on Thin Ice, scientists are increasingly turning to satellites to monitor glaciers. Still ahead, what they're seeing that could impact the West Coast. Plus, we look at what this means for Pacific Northwest agriculture. We'll hear from a farmer who says he's already feeling the impacts of less water. Welcome back. The effects of glaciers melting at a record rate are hitting our region in a number of ways. Jude Binkley shows us how changes in distant polar ice could disrupt ocean currents, climate, and our water supply.
Melting glaciers can mean much more than rising sea levels. Research reveals it also fundamentally changes the ocean's circulation, temperature, and chemistry in ways that could impact the coasts right here in the Northwest. The Earth's glaciers hold massive amounts of frozen water, and as they melt at unprecedented rates, they're creating unexpected consequences for our oceans.
And the ice sheets have these huge amounts of liquid water locked into them. It's frozen right now. But if it melts, it goes out in the oceans, and that causes sea level to rise.
Glaciologist Ellen Inderlin at Boise State University uses satellite imaging to track how fast icebergs are melting. That meltwater is already reshaping ocean systems and influencing conditions along the Pacific Northwest and beyond.
And the icebergs go out in the ocean, float away, and you can imagine they're little pockets of fresh water. So they're frozen pockets of fresh water that are drifting out in the ocean and eventually melt, and they spread that fresh water out.
The ocean's waters circulate through what's called the global ocean conveyor belt, a system that moves heat from the equator toward the poles.
So by the time it gets up towards these polar regions, so top of the Earth, bottom of the Earth, it's really salty. And that salt is actually what makes it dense, it makes it heavy. And so that makes the water sink, and then that drives this global ocean circulation.
As ocean water moves toward the poles, heat causes it to evaporate, leaving behind saltier, heavier water. That dense water sinks, helping to drive a global circulation system that regulates climate. But when glaciers melt, they release huge volumes of fresh water, which can slow or even disrupt the flow of ocean currents.
If we pump out too much ice out into the oceans from Greenland and Antarctica, and depending on sort of where it melts, how it gets mixed in, it can slow down or actually shut down global ocean circulation.
That shift in ocean flows could have far-reaching consequences for global climate patterns, and the Pacific Northwest is feeling the impact. In Idaho, earlier snowmelt and reduced summer stream flow are straining irrigation systems in the Boise River Basin, impacting crops. And in Washington State and Oregon, shrinking glaciers feed rivers and coastal waters, affecting salmon runs, hydropower, and even drinking water.
Our climate influences things like where we can grow crops. So we alter ocean circulation, that's going to change our atmospheric circulation, which is then going to even change like our long-standing agricultural practices.
Jude Binkley, Environment Northwest.
Drought conditions are worsening across the Pacific Northwest every summer. That's fueled by mountain snowpack and glaciers melting earlier than normal. Cody Proctor reports on concerns about the dwindling water supply affecting one of the Northwest's biggest industries.
Right behind me is just a small portion of the cows here at J&K Dairy just outside of Sunnyside. We're visiting on one of the hottest days of the summer so far. And even with temperatures like this, they're making sure their cows are staying as cool as possible, even when water is so precious.
The noise is constant at J&K Dairy, from fans to water soakers. Trying to beat the summer heat isn't easy. With 3,000 dairy cows and 2,000 acres for growing crops like corn and wine grapes, that job gets harder for farmer Jason Sheehan when water's scarce.
Right now, the biggest issue we're dealing with is the irrigation water.
Sheehan's part of the Rosa Irrigation District in the Yakima Valley, where he serves as a board director. They're right in the middle of their third drought in a row.
In a drought like this year, we're actually getting 42% of our water. So less than half of what we're supposed to get.
The Rosa Irrigation District relies heavily on the snowpack in the mountains, but this year, those crucial winter accumulations just aren't there. What started off as a promising year quickly melted faster than expected. The dry spring led to Washington state officials declaring a drought emergency in several counties. The snowpack isn't the only thing melting faster than expected, something University of Idaho glaciologist Tim Bartholomew knows all too well.
The glaciers in the Northwest is sort of similar to the condition of glaciers across the Earth, and that's generally that the glaciers are melting more than they're gaining.
He says glaciers across the Northwest are losing an average of 2 feet of ice every year. He points to climate change and the warmer temperatures that come with it for the faster melt.
The temperatures are warmer in the summer than they used to be, and that melts the glaciers a little bit faster. In the exact same way, the snowpack also melts a little bit faster come the spring.
It's also why we're seeing less mountain snow in the first place.
So in the last 70 years or so, we've seen, in a lot of places, we still have snow. We still get snowstorms, but the snow that makes it to spring is now less than it used to be.
When you have one drought or maybe two droughts, you can kind of get through things, but the third year you start to really stress crops.
With less water, Sheehan's not growing anything on about a third of his land.
Which is a cost because then we've got to buy feed for the cows.
The farm does have its own water cycle to get as much as they can out of each drop. One cycle starts with using water to cool the milk. It's then used to water the cows, cool them off with the soakers, and to flush the barn alleys of waste.
That water is never used just once, it's always captured. And once all that water is captured in our lagoons, we use it to fertilize our fields.
But the future remains uncertain, with concerns about next year already sprouting.
Because the reservoirs now are at some of the lowest levels and they've got to refill. And if you don't get the reservoirs to start refilling, we're going to be in another drought next year.
For Environment Northwest, I'm Cody Proctor.
Up next, I sit down with meteorologist Rich Marriott, who spent decades studying glaciers in the Pacific Northwest. He even lived on one. He weighs in on the massive changes we're seeing now. Well, he's been forecasting at King 5 for almost 38 years, but prior to that, he had another incredible career. Meteorologist Rich Marriott joins me now. Rich, you founded the Northwest Avalanche Center 50 years ago.
Right, this is coming December, yep.
That was your winter job.
That was my winter job,
in the
that's
70s
right.
and 80s. You had a summer job as well.
Right, with seasonal work there, but yeah, my professor at the University of Washington, who I got my degree from, who I was working with there, he also was a glaciologist and ran a research station on the Blue Glacier in the Olympics since 1957.
Oh.
Yeah, and so he had all of his graduate students go up and spend some time for at least one summer. And I went up there and I fell in love with it. And he was getting close to retirement, so I took it over.
Oh my goodness. So you lived on the Blue Glacier on the Olympic Peninsula.
During the summer months, yeah.
During the summer, which years?
In 1976 through 1987.
And what did you do while you were up there?
We did some skiing, for one. We skied around the glacier, doing a lot of telemarking, but we were measuring, there were a whole lot of different experiments that were done up there during that time period, but we were measuring the mass balance of the glacier, basically how much water it gets from snow in the winter, how much melts off in the summer, and that's basically to measure the health of the glacier.
Wow, incredible. And you lived in a ranger station, correct?
Well, it was this station was built, the research station was built for the International Geophysical Year in 1957-58. And that's where they spent an entire year, including a winter there, which was a very crazy place to spend a winter because we had 100-mile-an-hour winds in the middle of summer up there.
Wow.
So it's the first thing storms encounter after they leave Japan, is the Olympic Mountains.
And logistically speaking, what is it like to live on a glacier?
Well, in the summertime, it's actually pretty warm, surprisingly. We lived in shorts most of the time.
I see you in shorts here a lot.
Yeah, and because it's hot on the snow, it really is. And we would go out and do our work, and we'd come back, and in the evening you would sit on the front porch and you see the Pacific out in the distance and Strait of Juan de Fuca over your shoulder. It was hard to beat. We did a lot of building maintenance to keep the place in shape as part of that, but we did a lot of different measures. One of the experiments we had was from the EPA, where they were measuring the air coming in off the Pacific because they thought it was perhaps the purest they were going to find in the United States because it's coming in after a long trip across the ocean. But mostly we're measuring the health of the glacier, which had been retreating since the early 1900s. It had lost about a half a mile's worth of ice between 1900 and 1953. And we had some very heavy snowfalls in the early 70s. And because of that, when I was up there, the current terminus had started to advance a little bit, but since then, it has been retreating, and it's probably lost, I don't know, I would guess just roughly about maybe 100 meters from the terminus, and a lot in terms of the thickness. We had that number a few minutes ago about how much has been lost.
And let's talk about that change. So you were there in the 70s and 80s. You most recently went back in 2012.
Right.
What does it look like when you can actually see the change?
There's the terminus, but then just the physical glacier itself, to look at it, it's smaller, and there's a lot more rocks out there than it used to be. And the other thing we watch is where the snow line is on the glacier, and it's way up glacier really early in the season now. And part of that, our winters overall with climate change are getting warmer, so a lot of the precipitation that gets up there falls as rain rather than as snow. So it doesn't make any deposits in its account to get withdrawn during the summer. So summers are drier and warmer, winters are warmer and wet, and it's not a good equation for a glacier.
Yeah, thank you, Rich, so much for your insight. As we wrap up our series, Glaciers on Thin Ice, the message from researchers is clear. Our glaciers are melting at a record rate, and the pace is only expected to accelerate. Their advice, get out and enjoy them while you can. Thanks for being with us.